All right, welcome everybody to another week of Mini Analytics Monday. With us today is Rami Crispin. Rami is a data scientist who mainly focuses on time series analysis and forecasting applications. He is the author of the hands-on time series analysis with R and several R packages, including the TS Studio package for time series analysis and forecasting applications. Since the beginning of the COVID-19 outbreak, he wrote dataset packages and created dashboards for tracking the outbreak, such as coronavirus, COVID-19 Italy, etc. So with that, Rami, I'm gonna hand this to you.
Thank you, Kim. Hi, everyone. I would like to first thank everyone for joining today this meetup. When I started to talk with Kim about this meetup, so the first thing I asked her about the audience and to get a sense who is going to join today. So this project is a hard project, but the talk today is more general. You don't necessarily need to know how to understand the concept. It's more about what is the Covid19R project. So with that, this is the agenda for today. We'll start about talking what is the concept of R data package, and then we'll jump to the Covid19R project. We show some example of how we are handling the data, and then we can have some time to Q&A. So the first thing I want to emphasize who I'm not by far an expert for biostatistician, disease, or the corona or COVID-19 outbreak. So I'm not going to talk about modeling. It's not my domain knowledge. I'm more focusing on the data side. So like Kim introduced me, I'm a data scientist. I love our stats. I'm mainly focused on time series analysis. I'm author of wrote a book about time series analysis with R, and also developed several packages, mainly in the domain of time series analysis. So I can say I am a time series person. And before we will jump and talk about what is the Covid19R project, just give you a brief introduction about the concept of R package. So the idea in R, unlike I think other languages such as Python, that you can host data within a package. And this is simply allow you to either help to communicate the package functionality. So for example, if you're developing a package for time series analysis, such as the TS Studio, and you want to show how function work in the manual of the package, you need some data. So instead of loading some CSV file and demonstrate how the function is working, you store it in the package itself. One of the main famous, if you're familiar with R, with ggplot2 package, there is the diamond dataset. There is, of course, the data package, which hosts hundreds of examples and so on. The next type of a data package are the one that just provide data. So they are not providing functionality, and they just some example. So for example, the UK grid and the US grid is a package that I created to show how time series with multi-seasonality look like. And the last is package that enable us to do some analysis of historical events or educational purpose. So for example, would be one of the most famous in the domain of machine learning is the IRIS dataset for cluster analysis and classification. There is the Titanic, and those are just for educational purpose. The main advantage of having a data package is that it's easy to create. It's very straightforward to create a data package. It's enable the data to be very accessible. It's in the namespace of the package. So once you load the package, you install it and load it. You just call the data and it's there. And the last and not least, it's keep the data attributes, and I think it's also something important. So when you're loading CSV file, but you have date or any other columns, the attribute is lost, and the way that you save it in our package, this is the way that you load it. So if you save it as a date object, it will stay date object. The downside of our package that they are not alternative for API. So if you really want to update your data, probably it's not the most sufficient way to keep your data. Also, there is a size limitation. CRAN is the organization that hosts the package, limit to the size of the package once installed to 5 megabytes, which is fairly small. So this is another limitation. And if you think about the structure of the process of creating our data package is straightforward. You need to have some data sources. So for example, in the coronavirus, I'm using Johns Hopkins repository to pull the data. For the US grid, I'm using the EIA API to pull the US electricity data. And for the UK grid, I'm using flat files. And then should be some kind of scripting file that go and pull the data, clean it, reformat it the way that the author think the data should be, and save it. So typically it should be R file, but if it's more complex and some requirement of other tools, external tools, you can use Bash script, which is very efficient. Then there are several utility tools in R that make your life easy to keep the data. So use this is one of the package and test it. All of it are kind of like weird names, but there are cool tools that enable you to save the data in a straightforward manner. And then last and not least is the automation part of it. And this is something I learned while actually working on the coronavirus package. There is several tools that are available. One of them is the GitHub Action that enable you to run a unit test and also to schedule or call a job a cron job to refresh the data. So it's tools that if you're using GitHub, I recommend to check them. So why COVID-19 data package is different from the standard data package? So if you think about the Irish data set compared to coronavirus data sets, they are different because all the COVID-19 data are tracking an ongoing event, which is, I think, the first time that actually we have an ongoing event that people start to create packages to track this, the data that related to this event. Also, there is uncertainty that related to this event. When I started to pull the data from the Johns Hopkins repo to package it into the coronavirus package, the data kept changing on a daily basis. And then I had to spend nights overnight just to update the code to make sure that the structure of the data stay the same. And there are data errors. Johns Hopkins are doing a great job to collect the data, but they are relying on external resources. And those resources sometimes make errors when it's a manual process in some cases. And it's very hard to validate if you have some discrepancy in the data, if it's coming from error or there is a real reason for that. Then, as it's ongoing event and people like what was like a last month seems like a far history, the data need to get updated on a daily basis at least. And this is another challenge that typical our data packages is not really built for. And on the right, you can see a list of our packages that are focused on COVID-19 data. And this is thanks for Dr. Mine Randell that created this repo with all the resources for our link is available over there for the COVID-19 data. So, and this is just an example of my commits. And as you can see, since I started to work on the COVID-19 datasets, the amount of effort is significantly higher than what used to my normal routine contribution for open source projects. So I thought about, before jumping to introduce the Covid19R project, to show like the timeline and what led, how we came out to start this project. And I didn't mention before, but I'm working on this project along with Amanda Dobine and Jared Byron's, that we started this project together. So early in February, I started to realize people start to talk about the coronavirus. At that time, it was still coronavirus. And it was still mainly problem of China. They start to go mainly, like the main cases that were outside of China were countries around China, but it was mainly, at that time, the focus was in China. And I was, at February 8th, was looking for the data. I'm a time series. I thought maybe I can take it as a time series and see what I can do as a time series analysis project. And after a day, I found this repo of John Hopkins, and 4 days after, I created a package. It was on my GitHub account. At that time, I realized that time series analysis probably won't be the best tool to analyze it. And I decided at that point that I leave the analysis part to the expert, but focused on the data. 10 days after I started to work on, I had the package on the repo. It was already in Crane, and then start the journey. So on March, it was mainly focusing on issue with the data. The data kept changing on every day. At the beginning, there was a different structure. There were the US states were still in these data sets, and then they were removed. The recovery cases were removed, and so on. And like there's a lot of nights, long nights, working on fixing those issues and another issues. People sending issue in my repository, and you feel obligated to answer them. But it's very hard to explain that this is not your fault. You're just pulling the data from another resource. And then there were a couple of pull requests that came, and one of them from Jared about how to create visualization for improve the data and create a supporting visualization with maps. Another pull request was from Amanda about how to incorporate her package that she she developed a package for the US data, and how to incorporate with the coronavirus package. We started to talk about it, and we realized that we're all talking in a different language, each one using a different structure of data. So if you want to plot the COVID-19 data on a map, you need to make sure that your labels are aligned with the GEOS official data. So when you merge, you will have a real merge. And we start to debug it and realize that the coronavirus, probably like the structure as it is probably not the best or the optimal structure. And this is how we started to work on the Covid19R project. And the goal was to create a uniform structure for the data, that no matter if you are packaging the worldwide COVID-19 data or the US or France, it still will have the same structure that a user can really understand when you open it what he see or she see. And then about 2 weeks ago, we actually, it was like the official release of the project. So with that, we can see what the project is about. So I think if there is one thing that I want that people will take from this meetup about the Covid19R project, that it is set a standard for the data. It's a uniform standard for the data. It's a tidy format. And no matter what data set it is, it will always have those fields, so which is the date, the location type. So in this case, this is the New York Times data set. So it's a state for the state, and you have another data set for the county. So the location type will be the county, and so on. And then the location code. It's something I will show the example later, but there are so many ways to plot and tools that support plot of mapping data on the maps. and you need to have some kind of like a location to merge with the geometric data. So this is an example that we provide. In the US, there is the FIBS codes, and we provide the location, and the next field is provide the type of code that we used. Then the user can merge with the corresponding data fast without be worried that there is some kind of discrepancy of the columns or the labels that we are using. So in this example, when you take those location code, it's straightforward to create a map, and I will show this example later on. Another thing is the data cap update. We created something similar to API structure that every day, every 4 hours, I think the cadence, that the sculptor is going and go to the resources, run the script, pull the data. And when you're loading it's not like a typical data package. When you load the package, you're loading a function that go and script the data from the source. So this allows you to, whenever you open your session, to load the most recent data. And it's easy to access. And the goal is to create a contributors committee. We created a document about how a person that wants to contribute can go and create his own COVID-19 package based on this format. So we want to make sure that the entry bar to write our package is as low as possible by providing as much tools available for user to create their own package. So we create a template about the structure of a package. We create a documentation and examples in the GitHub repository. And the last thing is that we want to also to make sure that the data is clear, the quality of the data. And one of the things that we want to have is all the unit tests that involve on the process. So far, there are about 11-ish packages in the project. The COVID19R is the main package. You can think about like it's the package that creates the API that you don't necessarily to load the other package, and it's like a centralized package that you can go and see to get the names of the dataset available on the project and load them directly from this package. And the COVID19R data is where we are storing the data. Data is also available in CSV format. And the idea is that not only our user can use it, also if non-our users, you don't need to know how, you can go and pull the CSV and do your analysis or whatever you wish to do with the data on other languages, either from Excel to Python or any other tool. And there is the New York Times datasets. There is France, Canada, Switzerland, Italy, and this is package that Jared started to work recently. Is about the mobility data that Apple released recently. One thing that I want to go over it, and I talked a little bit about in the introduction, is the continuous integration. This is one of the, I think, like one of the lessons I learned, and it was new for me when I started to work on this project, is the GitHub action. And the GitHub action, if you're developing any package, or no matter if it's R package or other language, and you want to automate this process, I recommend to start using. It's very straightforward. You are creating a YAML file, you set some parameters, and you can communicate and run some scheduled jobs with your repository. This is a really wonderful tool to use. In this case, this is the code for running a cron job to update the data for the project. Another thing that I want to emphasize is that this is still a work in progress. We still didn't really get to where we want to go. But I think the skeleton is there, and there is enough resources that people can go and start to contribute to the project. And the project is an open source, completely open source project. And we really encourage other people to come and join and build their own packages. So with that, I will just jump for example. So just to go to the example, just show you what is available on the repository. So the repository is GitHub. It's called Covid19R. You have the documentation, which I will show in a second. You have a template for a package. So if someone wants to create his own package, you can go and clone it and just start. There's all the instruction about how to create your own package, and just the only thing that you need to have basically is data resource and a file that script the data and clean it to the format that required to be in this project. There is already tools like Travis and vignettes examples and unit test examples that you just need to modify to adapt and modify the code to fit your data. Another thing that there is here in this repository, I think it should be somewhere here. Jared create a mapping of data resources that are available, just waiting someone to come and start to collect them. So there are more data than we can actually process and package. But if someone looking for a side project want to contribute or want to get idea about the data on the Covid19R package, there is issue with a list of different data sources. So for example, from Uruguay, Slovenia, Estonia, Denmark, and so on, resources that are available, either APIs, GitHub repository, and so on. They just need someone to go and link it to and package it. This is the project document. We created a bookdown. A bookdown is a R Markdown format that allows you to create some type of book. And in this case, we use it to create a project documentation with the instruction about how to build a new data package, how to get started, how to submit it eventually. And one thing that I want to show, and this is probably like what makes this project unique, is the data format, the data structure. So this I already talked about before about it. We have a uniform column fields, but we also create a vocabulary. So when you go and see the data type, you see cases type or def total or so on. If you go to the standardized vocabulary, you can actually get more description about what each column represents, and also you can get more sense about the location code and where you can find the data that corresponding to do the merge with maps, and what is the data types that we are using. This enables to create a standard and a uniform format. So whenever you see tested total, you know that this is the cumulative number of tests that perform on a given date. So this is a short example. It's R, but I will just go verbally about what I'm showing here. You don't really need to know R, just the concept about how we can utilize it. So first, we're loading the packages. I'm loading in this case, the Covid19NY times, which is the wrapper for the New York Times datasets that Jared created. Loading the dplyr and tidyr packages for manipulating the data. The SF package is to get the geometric shapes for mapping. Tigris package is to get the census data. We're going to work on show here the county level. So I want to get information about the county level in the US. And MapView is the wrapper for the JavaScript leaflet package for plotting maps. So the first thing you can see that when you're using this function, refresh COVID-19 New York Times counties, you will get the most updated data for the COVID-19. And this is from yesterday. So the data, the most refreshed data is available in this data set is automatically updated on cron job, and you can get anything that's available from yesterday and backward. And as you can see, the structure is the same. The first field is the date, the location. So it's in this case, it's a county. The location code, and we're using here the FIPS code, and then the data type. So you have your case total and death total on the county level. On the state level, there are more information, but for the county, this is what the New York Times provide. So first, we will start with some statistical summary. For example, if you want to get, I just choose a random day on the May 14, a summary of what are the counties with the highest number of cases. So I will filter the data by this date. I will transform the data from the, so it's not white for too long, it's long to white format. And then I will calculate the death rate and sort by the highest counties. So I'm taking the counties data in the US, filtering to May 14, spread it by the data type and the values I'm taking from the number of cases, and then I'm sorting it by the top 15 counties. So you can see probably something that you already know, that New York is the highest number of cases. And I think there is some issue with New York in the data that they don't provide the county level, and it's a city level. But the rest is a county level, and you can see that the next after is Illinois, County Cork, and then another county is in New York, and so on. Interesting to see that there is no really consistency about the death rate. And maybe it's something that we cannot conclude from this data, but it will be interesting analysis to take the data and research why there is discrepancy on the death rate. Maybe the population age is different. Maybe when you have more people that are infected, the ability to provide ventilation is low, like was in Italy, and then maybe it goes to higher death rate. I don't know, I'm just asking, and maybe if someone wants to take it as a project, could be something interesting to research, and I'm sure people are already doing it. So the next thing that I will show is how to create a whole plate maps, which is my favorite mapping tools. I will start with plotting the US overall, then I will show only the lower 48 states. And then since we are in a Minnesota meetup, I will show the data for Minnesota. So for those who are familiar with our, again, it's really straightforward. And this is, I guess, what I love about this project. And it was not possible to do it with, for example, with the coronavirus that I started with. You get to do a lot of merging. Here, you start by filtering the data to the same data that we use, and we show only the total cases up to May 14. The next thing is to get the geometric data by using the SF package and load the data. I think that probably I missed the code somewhere here before. Or maybe I'm doing it later on. So once I'm having the county map, I'm merging the data frame that I created here with the county. And yeah, I think that it's not showing in the code, but I can show it over here how it's work. I just put it included false, but generally, like this is how I create the geospatial data. I'm pulling it from the SF package, and it just gives me the corresponding data for the county of the US. So once we have the same code as it used in the package, I can merge the labels that are available on the datasets, the New York Times dataset, and it automatically will merge it with the one available on the county map dataset. And then we can just plot as it is with the map view package. You can say that because we are showing all US states and territories, so it's spread all worldwide because you have, I think it's over here, it's a GAM, or I'm not sure if I pronounced it correctly. You have your Hawaii, you have Alaska, but you can zoom in and get more like sense of how does it look. And generally, like I'm just using a map view package, but you can do it with ggplot, plotly, or any other package. So it's just matter of preference. It will be the same. For sometimes it's maybe not the most convenient way to look at the data, and people are more interested in the 48 states. So in this case, I'm just going to remove the territories and Alaska and Hawaii, and focus on the lower 48 states and get this plot. One of the things that I use here, I set the values that I want to set the color palette scale. You can control it and set like based on the data. I think there is also option to automate it to create some log scales or anything similar. But the idea here is to get the data, and once it's interactive. So for example, I guess this is Los Angeles. You can open it and get more information, and you can edit it. So this is why I like this package, that you can get a lot of information. It's interactive, and you can play with it. Similar, I will do the same for Minnesota. If I want to plot only cases for Minnesota, I will filter Minnesota. Here I did adjustment for the color scale. The max number of cases, I think it's in this county with 4,300. So I just cap it at 5,000. And you can get how the cases in Minnesota distributed by the county. So I'm not familiar with Minnesota, but I guess that because this is the main cities in Minnesota, it's more dense population, and that's why you see here the highest number of cases. And as you go far away, it's dropped down. I can assume that those are rural area or not populated, so that's why you see a low number of cases. Again, I'm not familiar with the geographic of Minnesota. But the idea is that you can do it if you are now taking another package, you can really repeat it. So if I will go to let's take another example, Swiss. So this package provides COVID-19 data for Switzerland and a Principality of Liechtenstein. And similarly, you can do the same exercise. It's follow the same structure. In this case, I'm merging data from the R natural earth because it's using different code. And you can see that you can get the same results. And here is also an example of if you want to do it with different package such as ggplot. The idea is the same. Once you merge it with the geometric data, it doesn't matter which package you're using. I just need to support mapping. So one thing I want to, before moving to the QA, I want to thanks all the people that are contributing to this project. Besides, I'm not the only person that's running this project. So Amanda, Dobine, and Gerard, that I start to work with them at the beginning, and then Morgan, the Basque clan, joined us recently, contributing for the data from Canada. And generally, this project is open source. We are really welcoming anyone that wants to come to contribute. I think there's more data that we can process, and we encourage other people that have passion to data, want to help other people with the data, to come and contribute. We have a Slack channel if anyone wants to join, and if anyone has questions, you can contact us. We are more than happy to help people to onboard to this project. So with that, we can jump for question if there is any.
Thank you, Rami. One question we have from our audience is about how we can install the package on our own computer. Could you go through briefly, like whether it's on CRAN and how to install? And I also see that you have like multiple packages within Covid19R, like probably just a little bit more detail on how they all work.
Yeah, so some of the packages are already in CRAN, so you can just go, for example, if you go to CRAN and do install package COVID-19 New York Times, you will find it. The Swiss is not in CRAN yet. The mobile is not yet in CRAN. I think also Canada is not yet. France in CRAN, and there are other like packages that are already in CRAN. But basically, if you go here, there are more resources in the COVID19R project repository. You can see if you go to each package. So, for example, let's see, COVID19R, you will have more documentation, and you can see if it's in CRAN or not. So this time it's still like in experimental, and we are kind of like trying to figure out like how the funnel structure. So we kind of like want to get feedback from users about what's working and what is not working before we're submitting it to CRAN. But the goal is eventually to get all the packages to CRAN. And if it's not in CRAN, you can use either the DevTools or remote package to install. So you have you should have like on any of the packages, the format is the same about the install. There is an instruction about installation or how to get the data. So this is like an example. This is the COVID19R. This is the centralized package that you can get information about all the datasets that are available in a project. You can think about it as an API. So if you do go to this package and load it, you can get like the get COVID-19 data info will give you all the data sources available on this project. And then you can just go and use the following function, get COVID-19 dataset within one of the names of the package, and it will fetch the data to your machine. I hope it's a long answer. I hope I answered the question.
Yeah, that answers the question. Thank you. And I think one other question that I have is that so you showed us briefly of all the different data sources that are yet to be included in the package. So if I were to be interested in contributing, how much would I need to know, and where do you recommend us starting?
So I think you need to have a basic knowledge in R, the ability to take data and manipulate it. it's a good start. To create a package is straightforward. Actually, packaging now to create them is it's amazing how easy to create package. Before I started to create package, I always thought that creating package is something that you need to be highly welcome to to build them, but apparently it's very simple, mainly because highly welcome create all those tools to make them simple. I can recommend, if you never build a package, so there is a short book that idly we can create. It's called the R packages. That really go step by step about how to create a package. If you're already familiar with R, I think the documentation there is a good instruction about how to start. There is few chapters that just focusing how to build your own COVID-19 dataset. It's going to like the small details about how to build a unit test, how to create the README, and what badges you should use. And if someone really interested and want to start and have feedback about what is missing, we will be happy to hear. The goal is that we try to make it as easy as possible that people with less experience can come and join. So we have, again, a Slack channel that people are asking questions over there about different parts. And we just encourage people to ask open issue or ping us on Slack or any other resource. We are happy to help.
All right. And we have a question from Alison Link. Are you noticing any major differences in the kinds of data different countries are making available, or is it pretty similar? So, for example, broken down by gender, age, or additional count variables such as, suspected cases, number of tests, and other things.
Yeah, so the data I think one of my main takeout, and I was joking about it. I don't know if it was funny for some people, but that I hope that all the world organization that taking care for this pandemic, the European and like the World Organization and in the US, they're doing better job than they are handling the data. Because in most of the cases, there is no API, or there is like in the European Organization for Health, which is kind of like parallel to the CDC in the US, they provide Excel files. It's kind of like feel that we need also to think about the data, because data is important for making decisions, and we need to make sure that there is some kind of like flow for the data and some standards. And unfortunately, even if the US, I'm not talking about different countries, in the US, you have each states provide different fields. So sometimes it's very challenging, even if you're talking about one country, but with different states, that each one provide different fields. Also, I worked on the COVID-19 Swiss, and in the canton level, each canton provide, like there is the basic one, but each one might provide different fields. Like not all of them provide how many tests they performed. So it's challenging to collapse the data, but that's why we created like the standard, like at least like the minimum standard that you need to have, and a flexibility to host as many as fields as possible.
And we have another question also from Alison Link. Would your current data structure be able to accommodate demographic breakdown variables like gender and age? Or is that in your plan for future?
It's a good question. Currently, we don't have this breakdown because most of the resources don't provide this information. But I think if there's going to be more data available, maybe we definitely should have some, maybe change like add some fields that provide some kind of like demographic data. I think it's very interesting, but there is, at this point, it's more like aggregate data that's available if it's published. And it's probably in the future, we'll probably have more data as we move forward with the collection of the data, and there are more conclusion about the virus.
Mm-hmm. So we have one question from Satel Xiang. Sorry if I messed up your name. So the question is the number of individuals tested in each US county available?
No, I don't think it's available. Some states provide this information, others don't. That's why I think that in the New York Times county data, this field is not available. There might be other resources. So if you go, I'm not sure which website is providing it, but there is a website that's actually ranking the states by the quality of the data they're providing for the COVID-19. For the state level, I think there is this information is available, at least for most of the states, but not on the county level, unfortunately.
Yeah, thank you. I think there's another question from Satel, but I'm not sure I understand the question. So they're asking, are the data at individual level available?
Not at this point. I think, yeah, I think that I saw at the beginning when just started, Singapore provided actually on the individual level.
Mm-hmm.
But then I think as more cases came, it was very hard to track individual level. And I think in most of the countries also there is privacy issue that you can identify people based on the like age group or location. So this data, it's very rare to find, and I think it's a more privacy issue.
Mm-hmm.
There is some, like the New York Health Department, the New York City Health Department provide aggregate level view. There is age groups, there is gender, and there is zip code. So you can actually get more information, but on an aggregate level.
All right, so we don't have any more questions in the YouTube chat. We'll give our audience a couple more minutes to put down any questions. But as we are waiting, is there anything else you like us to keep in mind once we start working with this project, either as a contributor or just a user?
I think the first thing is feedback, because the two of us are coming from different backgrounds, but I would consider ourselves as experienced R users, so we might miss some stuff that for non-experienced might be critical. So if you have feedback about how we can improve the process, we're happy to hear. And yeah, I think this is a super important purpose to help others by providing accessibility to the data. It's like literally the hashtag data for good. This is what the whole goal of this project, to make the data available. So I paused my time series package development since I think February. I had the plans to do some cool stuff in time series modeling that I had to pause. I paused my development of the TS Studio, that I have a lot of stuff to do there, just because I think it's important. So it's if anyone has spare time and want to contribute, welcome to join the project.
All right, so we have another question from Brian Lowe. I am a Python user. Is COVID19R data or COVID19NY times a better place to get data?
So you can either go to the source data to get the data if you want to get it directly, or you can actually go to the COVID-R data package, and there is a folder called data raw, and you can get the data over there. So this is the COVID-19 New York Times counties and the stats. So you can actually pull it from there if you take the raw file and just pull it. If you want to pull it to Python, it's easy to do it. And if one of the things that I forgot to mention when someone started to build his own package, that all the code is available. Like all the scripting code, how we clean the data is available. So you can actually just clone one of the packages and follow the logic. This is another way, like do reverse engineering, but in addition to the documentation that's available, you can always go and just check. There is usually a data raw folder that this is like I'll refresh the province level data. So in this case, I'm pulling the raw data from, this is the, for Italy, I'm pulling it from the Office of Civil, I forgot the full name, but there is like Italian office, official office that provides this information. I'm pulling it from there. I'm changing the names. Modifying the official data, and then I'm saving the data eventually to CSV file and to R data file. So all the information is available, and it's all open.
Okay. And then a question from Kevin Grady. Your examples are based upon total cases and deaths. To examine changes in daily cases or deaths, are you basically just comparing the most recent date to the date before it and comparing the difference?
Yeah, so in this case, it's the total. The coronavirus, the original package that is not officially part of this project because the data structure is different. Like this is what I started, and now I think that to change it now might be too late because there are too many people that are using it. But what I did, the John Hopkins are providing the aggregate level, and just took the difference from day to day, and it created like daily cases. I'm not sure if some packages, I need to check the vocabulary, but I think also some, like if there is need, we can create like a diff which provide the daily cases. I think there is, can you go and check quickly? Yeah, cases new. So if you have this field, it's just like a daily new cases. The downside of this, and I had spent a lot of time to explain people that filed issue, that sometimes when you have aggregate data, they are changing the data. So for example, if something you find out that last week you classify 100 people and it was false positive, you change it today. And this is end up that you have going to, when you compare today from detect the difference from today and yesterday, you might get negative cases. So this is one challenge when working on when using this. So not always it provide you the real picture because of those cases.
All right, thank you so much, Rami. It is wonderful having you sharing your project with us. And thank you everybody for tuning in. Next Monday, we will not have a mini analytics Monday as we are having Memorial Day. But we are hoping to see you back with us on June 1st. And our guest is Ryan Ambrose from General Mills. He will be talking about change management in a data-driven world. So again, thank you, Rami, and see you everybody again on June 1st.
Thank you, Kim. Thank you, everyone that came to the meetup.